from previously, I'm talking about the robot that we are really familiar with it, actually working in home automation system or maybe the automation system inside the factory. Actually, this kind of robot is not very socially interact with the human. So this kind of robot, we get nothing from it and they get nothing from it. Actually, we only get something that is already programmed to do for it. This kind of like very boring task that we already programmed it. So we need some kind of robot that can renewable data and learn from it. And this kind of robot will come up with a lot of the problems. So we are going to make the new robot to study them. So here it is. We need some robot that we can socially interact and workable with some application, right? So this kind of robot actually exists in our real world, but it's not accessible for everyone. So this kind of application is still limited for some application for maker or decoder, everyone that want to hand on the robot with their own mind and they want to using their imagination with it. So, so why do we need the cat or dog, something like that? Okay, it's very nice question for here. That's because of something that we already know, we already familiar with. We can really access into the data and we can tell them to something that we really want to talk with it. And that's it, the relationship between the human and machine is a good one because of if we want to learn as much as possible from human, we can actually make them interact more and we can make them really accessible for everyone to kind of like making the relation with it. So, okay, so let's get to the next topic here. We have how to build your own CATBOT. Okay, so the following here, that's what you need to build it. So you actually have to working with a lot of stuff that you need here, like the software stuff that you need to download into your computer. Actually, when you want to build the robot, you actually accessing to lots of the hardware. So sometimes that means you have to make your own too. So how are you going to do that? First of all, let me introduce you the CAD software that you can get it for free and it's pretty good to use. So I'm going to quit here and then I'm going to show you the CAD software that I'm using. Can everyone see it? So here it is, the part that we designed from the Fusion 360. It's pretty good one. Or if you prefer, the SolidWorks is good one too, but it's not for free, right? So everyone who trying to hand on the robotic, trying to make very low price cost as possible to accessible to the resources that you can actually working on it and just work. So the Fusion 360 is something you are looking for. So what is special on the Fusion 360 here? You can actually able to designing the circuit and import the circuit from the Eagle PCB software. You can export that in 3D file and you can export them into the Fusion 360. And here you can, as you can see, if you're working on some busless model or something like that, you can actually build them inside of the hardware, and you can make the Y out from it. It's a pretty good one. Okay, so let's go to the other one. So you need the GitHub account. Actually, you don't have to have it if you want to build one your own. But if you want to learn stuff from me, actually you can make the account in the GitHub, and you can actually just clone into your computer, and you can learn the hardware that I built in there, and even the software inside of there. Actually, it's not finished yet, but I will try to finish it, and you can download inside my GitHub. Okay, so I do know IDE and the STM32 core installed. Actually, the STM32 is from the last year. We have the problem with the core that we going to using with the Arduino. So it's because of it's not support with the Arduino. So Logic Clocks actually the one who made this possible by make the STM32 core, so we can actually using the Arduino with the STM32, and it's possible right now because of we can write the code very easily to using the syntax of the Arduino to code inside the STM32. And the other one is going to be the 3D printer, and you want to need the filament like the PLA or ABS filament. These are usually used in the 3D printer stuff. Okay, so you need the BOM of the MCU. Actually, the BOM is actually the bill of material, so that you can download it inside my GitHub after done everything else already, and you can order the part for your projects that you want to make. Okay, so you need the battery. The battery that you are going to use is going to be the 2-pack of the 7.4 volt 4000 milliamp. It's actually pretty good one for using with the robot in small pack size, because of the robot need dexterity and it need to move fast under the lowest weight, which is not going to losing the energy with the weight with the actuator. Okay, so the project that I'm working on here, we are going to using the Raspberry Pi Zero to build. So it's pretty cheap one, and you can actually connect it with the wireless and the micro SD card to write the image down and make the OS inside the SD card and using with the Raspberry Pi. Have anyone here ever using the Raspberry Pi before? Okay, so that's very accessible. So the USB hub, you need the USB hub to communicate with the serial protocol that we are going to communicate with the microcontroller right here. For example, that's the one that we are using. So you need the USB sound card. We're talking about it later, because of it's very important one for the robot that you need to make more applications. Okay, so go on here. So my first day, actually, we make the head of the robot that we are going to do is the CATBOT. We design everything for support the hardware that we are going to build inside, like the camera and also the processor that we are going to use, like the Raspberry Pi Zero to build and the night vision camera. So here it is, the night vision camera that we are already built in with the hardware that we just decided previously. Okay, so we have to print it part by part and then trying to assemble it inside the Fusion 360 previously that I just showed you, and separate them piece by piece and then send it into the 3D printer. So why do you need the assembly inside the Fusion 360? That's because of you want to make sure that the part that you made really able to assemble together. Sometimes you can build it separately, but it makes you not so sure about the design. What makes you can build is very beautifully done is going to be build them together, because of you already built the image in your mind and then you want to make it look like the one that's your imagination. Okay. So here it is, the one that I made it. We made it together. So you can see through everything inside of it before you build it. And yes, we already built the head of the CATBOT. And here it is. Really pretty, right? So, yeah. Actually, the one that's those one that you can see here is the ear of the CATBOT. It's not what I did. My mom did it. So, yeah. Give the good to her. Okay, so here it is. We're trying to upload the CATBOT installer into the head of the CATBOT. It's just like the movie, right? You have the head of the CATBOT and you can actually plug the USB inside the head and upload something else. Okay, yeah, this one is pretty good design one, because of when you want to take off the computer to programming or reprogramming something, make it inside the head is pretty cool. You don't want to take the body all the way with you. You just unplug the head. You can program it, right? Easy one. So yeah. Furthermore, after done installing the CATBOT, you can test the firmware. So in here, I'm going to using the Arduino Maker for the first version that I made. Because at that time, I don't know how to programming the STM32 yet. I don't know how to make the firmware from the kernel or anything else, but I just know Arduino. So I made it from it one, and then yes, it's working. And we're trying to using the other microcontroller next time. Right now, we're already using the STM32 for the official platform. So here this is the one that we already tested, and it can communicate with the digital communication like the SPI or maybe I2C or something like digital analog input output. You can do all of that through the Python code using the firmware that we just installed. Okay, so let's get back to the body of the CATBOT. We are going to familiar with the cat body, but we never know the anatomy inside of the CATBOT. The real cat, I mean. Actually, the cat, they have very high dexterity. So this is the one that we are going to study from it, because of it's already the one that we know as mammal species. So it's kind of like us, and then it has some kind of dexterity that we have to learn from it. If we could build a robot that can actually using this kind of dexterity, it would be very nice to accessible to the new learning of the robot field. Okay, so here it is. We build the body again inside of the cat, the real cat. You can just see inside. Here it is. So why do we need to build inside the cat body? That's because of we want to copy from the nature. We already have some very spectacular anatomy here. We don't need to rebuild all of those. We're just using the nature to inspire to build the body of the cat. Okay, so it is. We are going to printing the CATBOT body. Okay. and go on here. We design the bottom of the CATBOT, so we can actually make it support the servo motor, so that we can assembly inside very easily. When we want to remove it, just remove the screw. It's pretty easy assembly. And here we are done printing the CATBOT bottom. So yeah, and go on. We build the leg of the CATBOT. So the leg is pretty interesting. You can see the bar linkage here. The bar linkage here is actually connected with the hydraulic actuator. The hydraulic actuator that we are going to use here, we use the ER fluid to replace the valve, servo valve. Let's me talking in the last topic why we need the ER fluid. So here it is. You can see the feedback sensor from the sideway of it, right here. I don't know that anyone can see the mouse here. Okay, so you can see there. That one is the plate to locking with the feedback sensor. We're going to getting the data from it, like angle that is moved, and then the feedback from it. We can use it to learn the movement from the user that teaching it how to move it. Okay, so here it is. You can see we can embed the sensor inside the 3D printed part, so that we can actually embed inside the angle of the CATBOT leg. So here it is. It's the part of the foot of the CATBOT that we're printing. Yeah, go on. And here it is. We go back to the part that we all design inside the Fusion 360 again. Now we have to wire everything up, right? So we need to know how to navigate the wire through each piece of it. So we just making the hole through the leg here. Can you see that? Okay, this one. So we can actually keep the wire inside of the leg and make it more beautifully, and not going to make the movements fail. Okay, so go on. So here it is. It's very interesting part here. We make our own mainboard using the STM32 F091RC. This one is actually the microcontroller that we first try with the CATBOT, and it's actually working pretty well. And you can controlling the servo and control all kind of the sensor surrounded, like the sensing sensor that we are going to using in the CATBOT, and we're talking in another topic. So we have the driver, the IC driver here. The IC driver here is actually we're driving the solenoid valve in the first version. In our first version, we're not using the ER fluid, and it is a problem here. We are going to talking in the last topic here, and it's had the problem with the heat. It came up with the heat because of the electromagnetic is going to be heat up when you energize instantly into the coils. So here it is. It's the CATBOT circuit. Right. To install the STM32 into the board. Okay. Okay, let's go to the other one. So after you done install, here it is. You see here, you have the microcontroller, all kind of the microcontroller here. You have the series of the STM32, like Nucleo 144 and the Nucleo 64. Actually, the one that we are going to use is Nucleo 64. You might curious, what is the number behind it? Actually, the GPIO of it. You can see it, the Nucleo 144 is actually have the 144 pin. The GPIO output of the microcontroller is a lot of the resources that you can control it out there. You can control multiple pins of it. And Nucleo 64, yeah, makes sense. It has the 64 pin. Our format, like the one I'm using here, is the Nucleo 64. So here is the instruction how you are going to select the MCU and upload it. Okay, here it is. You just select the microcontroller that you are using. Okay, go on. And here's the setting of the, before you upload it, upload method. Going to select the mass storage. Let me show you something here. When you first plug it in, the STM32, you see the pop-up here, right? He's acting like the flash drive that you are using, or handy drive, something like that. It's just like the flash drive that you can actually put anything in it. So here this is a function that we already selected in the mass storage because it's act like that. Okay, so here it is. So you can visit this website for more information of how to install it. For more information, okay, so here. Okay, go on and upload the code into the microcontroller and let's have fun with it. So here it is. We have the code that we are going to make it to jump or something like that. You have to make the trajectory and make the goal for each angle to aiming into the position that you need in the path planning and motion planning. Okay, so here it is. The installation library that you need. This is all library that we are using in the CATBOT to make it work. Okay, so here it is. The first time that we make the body and head assembly together. Okay, and install the gyroscope inside the CATBOT. The gyroscope is actually, we're using the MPU 6050 for the stabilization, or you need to use the better version, you can use it too. Like the MPU 92 something, I can't remember the last code, but this kind of microcontroller, this kind of gyroscope is actually have the barometer inside too, and the compact. You can call it using the I2C to reading the data format. Okay, so go on. So here it is. We made the full body of the CATBOT now. But it's not done yet. We have to do a lot more. Okay, so here it is. We make the hydraulic tube to get inside the hydraulic. The hydraulic that we are using here, you may curious what it made of. Actually, it's just the silings. It's pretty easy to find one, and it's workable. But we want to make the official version one from the 3D printed part, which is I'm going to do inside the GitHub. And after done, yeah, you can download it to printing it. Okay, and here it is. So we going to testing the code now inside the CATBOT. That we able to using the camera or not, or the sensor is working or not. Everything just running, and we can see what the problem or what we need to add into it, and we can add into it later after then. Yeah, and yeah, everything is done now, just coding and coding again. A lot of the code that we have to go through into the CATBOT actually in the part of the microcontroller side and in the Python code too. Okay, so we do some face recognition with the CATBOT. At the first time we trying to using the CATBOT, we're using the night vision, which you can see it, the infrared there. Infrared is here. See? You can only see that in the camera because it's not visible to our eyes. So here the hard catch case, you want to training it to detecting multiple objects, but you have less time. You can either using the Cascade Trainer GUI, you can actually putting the picture data into it, and it's going to training the data for you to detecting some kind of the object that you want. Pretty easily done. Okay, so after done using the Cascade Trainer now, you will get the hard Cascade file in the XML file, and you can detecting the other animal now. You can make the CATBOT to detecting the cat and detecting the dog, something like that, or you can detecting the object, the other object that you need to teach it to learn from it. But it's may boring for you to using this kind of training algorithm to GUI to training a lot of the stuff like that. You may using the auto ML to using in that function later, but that we came up with the processing that you need or you require. Actually, the Raspberry Pi 0W is not going to give you that answer for sure. It's very fairly slow and it has low resources. So we are going to talking about the computer that we going to use with the real robot that we are going to make one after this prototype. So here it is. We made it to detecting the cat, right? Okay, so it can detecting the cat now with 98.2% accuracy. So yeah, here it is, the sound guard that I am talking about. So you need the sound guard to make the sound out of it, or maybe input the sound into it. Actually, using the normal microphone that you're using, just plug it in. Let me tell you why. That's because of the Raspberry Pi 0 came up with the DPO output, actually a lot of them, and it's not support with the audio output or input. So you need something that communicate like the sound card with the serial communication. So we're using the sound card for this reason, the USB sound card, and yes, it's working pretty well. So go on to the other one. So we're going to making the sensory input. This sensory input is actually the prototype. We trying to make the array of the sensor that you can get the force sensor, you can get sensory from it, and miniature radar into it, and it's actually feel the thing like we do, and maybe far more beyond. So you can add more sensor into it. So here is the microphone that we are using, and we're trying to make the speech recognition install it into the CATBOT. Okay. Let's go on to the other one. Okay, and here is the main problem that we getting right now. Because of using the solenoid valve, it's actually too big. And this is the main problem because of the fluid that we're using cannot control at all. The fluid that cannot control, that means you can't control the angle of the movement of the CATBOT. And that one is the one that we're trying to solve with the ER fluid. Because of the ER fluid actually act by the electricity that we initiate into it. And electricity that we initiate into it actually make the contraction between the molecule and make the contraction to make it stronger. And when it's stronger, the fluid is not movable. So when it's not movable, that means it's act like the valve. When it's act like the valve, we can actually control the fluid now without the problem, and we can control the hydraulic. So here it is the computer that we are using. Oh no, it's the, oh wait, the SPC computer that we are going to use with the real robot. It's actually pretty strong one, pretty powerful. And this one is the Snapdragon 4110C, okay, 410C. And then this one is pretty powerful for making the robot that we need. Okay, for the application in the future, we are going to looking for the convenient robot, or maybe more interaction with the social robot just by using the open source platform, actually accessible for the other people, and we can learn more from it and make the research in dexterity and intelligent robot system and more. Okay, so here is my GitHub, so you can visit inside my GitHub and you can download the CATBOT in there. Once it's done, you can searching for the CATBOT project and then you can download to use it. Okay, thank you for your attention.
Thank you, Korn. Does anybody have questions?
Why don't you use servo motor instead of hydraulic?
Actually, we're using the servo motor too inside the CATBOT.
I mean for the leg.
For the leg, that's because of we need the dexterity and we need to try the new actuator for it. We need to try the new actuator that we can get the dexterity very higher than the servo and its robot.
Can you tell me about the power source? I mean hydraulic power source.
Hydraulic power source is actually using the hydraulic pumps. You can use any water pump too, but it's not strong because of it had blast motor. And you can using the BLDC motor to replace an assembly inside and make your own hydraulic pump from the 3D printed part. So is this commercial? It's actually not commercial one. I will make it inside the GitHub, so you can download and make everything from there.
How fast? I mean, if you drive the leg, right? How fast to move?
It's actually up to the busless motor that we use. I'm not sure right now because I didn't make one yet. Because right now we're using the blast motor. So we can see the problem here. The blast motor is actually answer our question about the speed and pressure that we need. We need some kind of the motor that can give you very high pressure and robot. That's what we need. So any question?
Did you try with Raspberry Pi 3 for the V class?
Not yet, but we already have the version of the JSON Nano that we're going to using for the higher accuracy, machine learning, something like that we're working on. And we're trying to make the robot that really interact with the people. And that's kind of the computer, the SPC that we are using right now is very limited. We're just using the SNAPDRAGON right now for the form factor, the small form factor.